Good morning. Today we are to see topic about inorganic chemistry 1. It is inorganic uh, chains. Inorganic chains are closed as iso or hetero chains. Iso means same type of atom is present. Hetero means different kind of atom is present. So, some hetero-chain polymers such as silicones, polyphosphates, and recently boronitrides are a great commercial interest because they are used various industries. Are while isochain polymers are essentially only of scientific significance, it is usually only little amount compared to this heterochain. So heterochain is very application is very compared to this isochain polymers. Organic polymers. They are macromolecules which are formed by the catenation of elements other than carbon, because carbon normally polymers organic polymers are formed by carbon, but inorganic polymers are formed by other than carbon. It is called as inorganic polymers. Example for this silicon catenation. Catenation is defined as the binding of an element to itself through covalent bonds to form chain ring molecules. Examples: carbon is the most common element that exhibits catenation. So, carbon is a very good example. It can form long hydrocarbon chains and rings like benzene. Polycatenates. Silicates are salts containing of anions of silicon and oxygen. They are present mainly sand and other materials. They are many types of silicates because the silicon to oxygen ratio can vary widely. In all silicates, cover silicon atoms are found at the centers of tetrahedrons with the oxygen atom at the corners. The silicons are very structure of this silicon is tetravalent. Valence is tetravalent. It has oxidation state of 4 plus 4. Lack of silicate. The building blocks of silicate minerals are built up from the basic unit of silicate 4 ion Si4 4 minus Gs. The following structural representations. Uh, the silicon atom is conveniently bonded to four oxygen atoms. Each oxygen atom possesses formal negative charge, and hence for each tetrahedron has formal charge of minus 4. When linked together, the extended units are also negatively charged. Presence of these metallic ions such as calcium 2 plus or magnesium 2 plus are necessary for electrical neutrality. The covalent silicon oxygen bond having bond enthalpy of 466 kilojoules per mole inverse is particularly strong compared with the carbon-carbon which has a bond and enthalpy of 347 kilojoules per inverse. The linkage of SiO is very stable, and instead of existing the discrete units of Si4 4 minus ions, the silicates tend to form. Classification of silicates. Classic silicates are classified into orthosilicate, pyrosilicate, and cyclic silicates, chain silicate, sheet silicate, and 3D silicates. We will go to see about phosphonitrate chlorides. How to prepare this? By the reaction of this phosphorus pentachloride reaction with ammonia, phosphorus pentachloride when react with ammonia, it gives corresponding phosphonitrate chlorides. For example, n molecules of this BCl5 and n number of molecules of NH3 and produces PnCl to n times plus 3NHCl. We have to replace with the n equal to 3 to 7. Example, 3Cl5 reacts with 3N ammonia and produces PnCl2 thrice plus 9HCl. The 4 and next one is 4Cl5. 4 molecules of PCl5 and the 4 molecules of ammonia react with P and produces PnCl2 4 times and 12HCl, like this. By the reaction with this PCl5 with ammonium chloride and produces phosphonitrate chloride, when N equal to 3 to 7, N molecules of PCl5 and molecules of ammonium chloride produces PnCl2 N times plus 4 NCHL. Example 3 PCl3 plus 3 ammonium chloride and produces PnCl2 5 plus 9 HCl. And 4 molecules of wasp pentachloride and 4 molecules of 4 molecules of ammonium chloride and reacts and produces PnCl2 4 times. Phosphor nitric chloride properties. Physical properties, they have melting point 114 degrees Celsius and boiling point 156 degree at 1 atmospheric pressure. It is readily soluble in ether, benzene and carbon tetrachloride. So others solvents it doesn't dissolvent and dissolved by other solvents. NPCl2 phosphonitric chloride have melting point 123 Celsius and boiling point of 328.5 degrees Celsius. It has lower solubility in ether, benzene and carbon tetrachloride than NPCl2. Chemical properties, effect of heat. Uh, the cyclic tri- trimeric phosphonitric chloride are heated, then they are converted into their corresponding in trimer and tetramer respectively. It is a linear trimer and linear tetramer, but linear phosphonitric chloride are not affected by on heating. Plus is the cyclic trimeric and tetrameric polymeric polyphosphoric chlorides undergo pyrolysis and they can occur formation of the exohydroxy and octahydroxy derivative which can further undergo tautomerism. These compounds are polymeric organosylic derivatives containing SiO SI linkage. These are also called polysiloxanes. We can represent it by general R to SiON. This may be linear, cyclic, or cross-linked polymers and have very high thermal stability. Are therefore they called high temperature polymers because of the high thermal stability of SiO-Si chains. Chemists have prepared large variety of silicon polymers which are very useful in high temperature process. Therefore, these find uses in high temperature applications such as heat transfer agents and high performance elastomers such as quantities and are expected to have organic polymers which cannot withstand high temperatures.